Handheld gaming is sweet. I mean, I spent way too many hours trying to make it through this cave without Flash and Pokemon Blue on this, or watching my friends play GTA on this bad boy during recess. But ever since the Smacheezy. Let's call it Smacheezy. Ever since I first saw the Smacheezy in 2016, I knew I wanted to build my own Windows-powered handheld, and I tried. More than once. I mean, technically I did achieve my goal of building something that worked, but I was never really satisfied with the final product. It used laptop motherboards that weren't all that easy to acquire, and it wasn't designed and built to a standard that I would be comfortable in having others do the same. So while it was an excellent way to get into 3D modeling, Arduino programming, and 3D printing, they were very much all just prototypes. All that changes today. Here, I'm going to use the 13-inch framework laptop motherboard and design a chassis that anyone, including you, can build. We're going to have a complete framework-powered handheld that I've affectionately dubbed the FrameDeck. So when building a handheld, there's generally four main technological components that we're going to need: the motherboard, the battery, the screen, and the controller. For the first component, it's pretty clear that we're going to be using the Framework 13 motherboard. Its standard format means that future upgrades will be very simple and require no new chassis or chassis modifications for as long as Framework supports their own Framework 13 lineup. Without the expansion ports, it's very small at around 255mm, with the Wi-Fi module included, which is smaller than the overall footprint of the Asus Ally. So it is overall a good candidate for a handheld. I'm going to be using the i5-1135G7 Framework motherboard because it's the cheapest one they have, but if you're following along with the 13th gen, Ryzen, or newer CPU powered Framework mainboard, those will work too. I figured if people are going to be upgrading their Framework laptop motherboards, they might also be upgrading their batteries too. The benefits to using the stock battery are ease of setup, people might already have them, and we won't be using up a USB-C port for power. It might be a little hassle to fit it in, but because the dimensions are smaller than the main board itself, using the sandwich technique, the battery will work just fine. The screen was tough. In my previous project, I used a 7-inch TFT 600p screen, and while the size was decent, everything else was horrible. Viewing angles and colors were not it, and the 600p resolution just didn't scale well in Windows. So I scoured the vast expanse of AliExpress until I found this, a 7-inch IPS 1200p screen. 16x10 is cool, but the digitizer isn't mounted to the display and it'll require a separate cable, so we'll have to deal with that at a later point, but for now, it looks like it'll do. The controller was a bit of a gamble. I could have just gotten generic buttons, wired up to an Arduino, and called it a day. After all, that's what I did with the other ones. But in the spirit of upgradability and repairability, I thought, why not just put hot swappable mechanical switches? It will feel sweet, and it can be customized to whatever switches you prefer, as well as be easy to upgrade and repair. I'd have to learn how to design a PCB to wire those up, but that's a problem for future me. A little movie magic and voila, we have all the parts here. Time to wire everything up and sanity test check that everything works. Here with the Framework mainboard, we got 16 gigs of RAM and a 256 gig SSD loaded up with Windows 10. Battery works great, and as you can see, the display and digitizer are also connected, but not in the way I anticipated. The data for the screen works, we just need a USB-C to HDMI adapter, and then get a thin HDMI to mini HDMI cable for the screen's controller board. Not elegant, but it works. I'll have a list of all the parts with links below, as well as the total cost. This is where stuff gets a little less intuitive. For this, we're going to need a little lesson on the USB-C spec. With a normal USB-A port, we have 4 pins: ground, data line 1 and 2, and the VCC, or 5V line. No matter what device you plug this into, it will always supply 5 volts. Now, USB-C is a little different. As well as having the first 4 lanes, at its simplest, the USB-C cable has one additional line, the CC line. This CC line communicates with the device it's connected to and asks said device what voltage it requires. As long as the device on the other end is configured to tell the CC line, hey, I need X amount of voltage, it'll work. Now back to this mess. See, the controller board physically has a USB-C port, but it's wired as a USB-A port, so it doesn't have a CC line. Therefore, it expects 5 volts without saying it needs it. This is fine if we were using a USB-C to USB-A cable, but since we're going from the Framework's USB-C to the controller board's non-compliant USB-C, the Framework will supply 0 voltage. Same goes for the Arduino here. It physically has a USB-C port, but it's wired as a USB-A port. So I found this little guy, a USB-C data splitter. With this, we'll be able to just plug in a custom USB-C cable. I'll get into the wiring for this later, don't worry. And everything will work just dandy. I have these Thunderbolt extension cables so that we can route our free ports to the outside of the chassis for charging any GPU support. Now that we've tested all the electronics, it's time to work on the chassis. So this is where the real fun begins. First thing I did was load up Fusion 360 and start to model the framework motherboard. With a 3D model, it'll be easier to build a chassis around it. Now my previous attempts were built like bricks, and it's not particularly ergonomic to game on a brick. So instead of reinventing the wheel, I decided to look for inspiration, the Asus Ally. I got some photos from all sides online and started modeling the outside of the chassis. Here's a quick little time lapse of the first edition of the model. I might make a separate video on the entire design and how-tos of modeling handhelds, so if you guys are interested in that, let me know. This model only has one external port at the top, but thanks to the USB data splitter, I'll be able to add an additional Thunderbolt 3 port to the bottom as well. I'll admit, I didn't know how to design PCBs before I started this, but it turns out it's actually pretty easy. On EasyEDA's editor, all you need to do is go to the library, find the component you want, select as many as you need, place them on your editor, and wire them up. You can even view them with different silk screens and board colors when you're done, in 2D and in 3D. It's pretty sweet. I got them printed out at JLC PCB for pretty cheap. The first batch had errors, but round 2 was much better. I'm still not sure if mounting on the corners is the most ideal for this situation, but it'll do for now. Alright, so after a few hours of printing, here we have our first prototype. I had to print it out in 2 pieces because the Ender 3 V2 print bed I have is not large enough. You'll see there are a few red markings, which are changes that will be done in the next revision. I'll have a separate video with step-by-step instructions on how to assemble your own FrameDeck when the 3D model is finalized. Don't forget to leave a like if you're enjoying the video, and if you don't want to miss the next one, you can subscribe and turn on the notification bell. The quality of the shot is not very good as the file got corrupted and I lost some footage, specifically on the trigger and shoulder button assembly, but I'll go into more details in the how-to assembly video for that. So let's just speed up the assembly and cut to the first boot. Let's see. Brightness is pretty bright. There you go. Seems to work pretty well. Let's see if we can turn this into tablet mode. There you go. Very cool. Paint. Test out the digitizer here. Oops, can I drag this? There you go. I'm no artist, but this seems to work just fine, actually. There you go, thumbs up. All right, well, that's that, I guess. Yeah. All right, so we got a lot done in today's video. Next video, we're gonna finalize the 3D model. We're gonna write our code for the Arduino based controller and finish off the internal wiring. I'll see you all in the next one.